Hi, welcome to Project Obsidian. This is the kill chain track. I am Old Monk, and we're going to talk about detection engineering. In the next 1 hour, we're going to do two parts of detection engineering. The first part is going to be covered by me, where I'm going to take you through the what, the how, and the process of building detections. And then Cobalt Fox will come in and take you through a hands on process of actually building a detection on your SIM. Um, Old Monk, quick intro about myself. I've been in the intrusion detection and analysis space for the last 24 years. I've been building cybersecurity products for the last 20 odd years. And I've been helping customers detect threats, recover from threats, answer questions like what, how, who, when, what has been taken, um, things like that after a breach, right? So a lot of breach forensics kind of experience as well. This talk, we're going to call it breaking the rule for obvious reasons, is meant to be a 101 track so that you can, anybody who is aspiring to be in this space and specialize in detection engineering, this is a great starting point for that. So let's get started. So in the next 20-25 minutes, we're going to cover what is detection engineering, the trigger points of how you get started with the process, what that process looks like, and finally, we'll take you through um, some scenarios which you need to consider to, sort of up your skill in the detection engineering space. All right. So, what is detection engineering? Clearly, it's extremely complex. No, I put it there just to make it sound difficult, but it's actually not. It's your awareness of the cybersecurity threat landscape and where you are where you are able to understand what kind of vulnerabilities and how attacks exploit these vulnerabilities, being able to then write detection content which traps exactly those exploit areas, and being able to do that in a way where you are able to save time and speed up the analysis process and response process for your SOC. So, awareness of this entire journey and building detections that are effective is what detection engineering actually is. I hope I didn't overcomplicate something that was simple. All right, let's go next. What are the two trigger points? There are three trigger points actually, but I'm going to cover only two. Um, the first trigger point is when you wake up to a gun pointing at you and your friend is talking to you and telling you that, hey, there is a new RC that came up on a very popular software, and you got to wake up and build a detection that can pick this up over the wire on your endpoints in your system host, right? So this is a time trial where you are quickly going to create a detection and put it up so that you start seeing hits if your environment is getting attacked. Scenario one. Scenario two is where your threat hunting team comes back to you and tells you that, hey, we've found traces of this APT. We don't really know if this exists or not, but I want you to look at these campaigns and figure out what are the different attacks they use, and I want you to signature them so that if these APTs exist, we'll be able to pull them out and be proactively alerted. Right? So these are the two scenarios. The third scenario is when you have time beyond these two scenarios, and you have time to go figure out what the internet looks like, what kind of threat landscape you have. Of course, we'll talk about these scenarios and what kind of threat landscape you have, and what attacks you're probably going to see in your environment, and be able to prioritize those and build detections for those scenarios. So obviously, uh, thank you, Einstein. So you get woken up to these two scenarios, and this is when you start your detection engineering process. All right, so let's see what the process actually is, right? The process is a lot of study and research, being able to collect artifacts, being able to study these artifacts, of course, writing detection, testing those detections, documenting them, maintaining your detections going forward so that they remain healthy and accurate. So that's more of the process. We'll detail each section of this process and dive deeper into each of these sections and see what are the finer points there. Clearly, it's not a repeatable process, so there is no rinse repeat that can happen here. It's a journey that you got to take each of your detections through. All right, study and research. The first part of study and research is to understand your exposure, right? And understand how much of this, the internet, how much of attacks you're likely to see and what kind of attacks you're likely to see, right? So this is the most fundamental part of doing detection engineering, is to be able to visualize and imagine that these are the kind of this is actually not really art, it's a science, because all you need to do is understand what industry you belong to. Let's say you belong to the energy industry, you're oil and gas or electric utilities company, and you can now, this information is available very clearly of what kind of threat actors are hitting these industries, whether it could be industry specific, it could be geography specific, and what do these threat actors look like, what are the tools they're using, and what are the techniques they use to hit you, right? So being able to study that and identify what kind of targets your adversaries are coming and hitting. So targets could be certain applications that you use. So it might be SaaS applications that you use in your industry, which might be very specific. It could be applications that people use in your industry, which are specific. It could be IoTs, some kind of a IoT bridge, which your industry is known for using. Or specific kinds of users that specialize, right? I mean, there could be a specialist skill that use certain kinds of computers that are getting compromised. So it could be a direct hit, or it could be like a supply chain hit as well, right? So understanding the threat landscape is a big part of identifying attack and planning for attack scenarios. It always helps in using some kind of a framework to build your detections. The MITRE ATT&CK framework is a very, very popular framework. It is very widely used. It is very extensive as well. So using a framework always brings measurability into cybersecurity. And I'm a huge fan and proponent of building detections using a framework, because then you know that you have coverage and you're constantly improving. Because if you're not able to measure, you cannot improve, right? So that's why in my opinion, using a framework will always help. Prioritizing, obviously, you cannot cybersecurity is spreading every day, right? It's becoming larger and larger. And as I see myself over the last 20 years, my skill is sort of has shrunk and has become smaller and smaller. So I actually specialize in a very, very small part of cybersecurity. And I think as you move along, you will too, right? So when you specialize in such a small part of cybersecurity, you know that your attack surface is so wide and you don't have enough time or the tools to actually be able to write detections for every scenario out there. So therefore, you will need to Do you will need to figure out exposure, understand targets, and basis that prioritize what is easiest to detect and which of those detections have the highest impact. So this is how you will essentially make your grid: easiest to detect, lowest hanging fruits, slash which of these detections are probably going to yield the best results, right? So that's how you will sort of need to prioritize which ones you will work on first. On the let's say for instance the MITRE ATT&CK framework, you have multiple tactics, right? Which is these vertical columns which goes from left to right. It's very important to build detections which are spread across the kill chain, right? Uh, Most of us make this mistake of only building detections for the initial access phase, right? Because you want to detect exactly when it hit your environment, right? Yes, that's important, but it's also important to have detections throughout your kill chain going from left to right, where you are able to identify persistence, you are able to identify credential theft or credential misuse, or even somebody uh, zipping large amounts of files and writing big emails, for instance, right? So you need to be able to identify all these scenarios so that you have traps set across the kill chain, not just have top loaded detections, right? This is again a multiple different schools of thought. How do you build detections? How do you anchor these detections together? Do you build detections around resources, or do you build detections around suspects, or do you build detections around targets, right? What is the key artifact you're going to use to connect your detection? Is it going to be an IP address? Is it going to be a host? Is it going to be a file name? What are you going to anchor your detection against? And there is no right answer, frankly. Different kinds of detections will require you to build different anchor posts, and you can use multiple anchor posts to be able to build these detections and connect them to your system. Hope that makes sense. Next is actually building and testing. Sorry, building and trying and doing a POC of the detection that you're building. First thing is to go about when you're faced with a scenario when you have a vulnerability or some kind of RC or some exploit code available somewhere. It's very important to get your hands on it quickly, understand how that exploit actually functions. Um, look for POCs. There are malware databases available. Look at those. There are simulation platforms available. There are places like let's say a Virus Total or any run. They have there or a Malware Bazaar. They have such a lot of malware being reported. So you are able to, even from the learning perspective, you can look at these malwares and run it in your home lab, and you can actually figure that there are lots of common patterns that these malwares actually use to attack you, right? So whenever you have a trigger and you're called in to build a detection, if you have the awareness, you will know exactly which are the points on which you want to anchor your detections, right? So therefore, trying your trying the attack, it and sometimes it's not even code, it's sometimes a simple curl command and calling a URL which with a specific pattern, right? That you be able to simulate your attack as well. So once you simulate, you want to identify your indicator. What is the key aspect? What is the success? What is the key success area of this particular attack, where you be able to identify that in the wild and be able to pattern that and call it an attack when you see it. The most complex question by far is also that you need logs, packets, memory dumps, access to endpoints, right, to get your detections identified. Now, because you need such a lot of information, if you don't have this information, you're not going to be able to write that detection. So it's very important to go figure out what are the sources you have that you can use to build this detection, right? There is no point, usually it's an uphill task to get a new source inducted just for a specific detection. So the skill also lies in being able to use existing data sets to build a detection, right? So this is really a go figure problem, right? You need to actually figure this out in order to make it work. Finally, build that detection, engineer that detection. My quick tip over here is to always look for opportunities to use more than one log source to build a detection, right? Because when you have more than one log source, the possibility of this being a true positive is much higher, right? Now, this is the second level of validation, is what this industry calls attribution. Attribution is when you take a particular detection and then look up third party information databases to identify if you got it right or not. So using lookups, third party lookups to, let's say, a domain tools, or let's say a Shodan, or VirusTotal, or even Alienwald OTX, or if your enterprise has got access to some tip platforms, right? Be able to look up to those tip platforms and figure out if they are seeing similar activity or not, right? So this validation will building detections with more than one source and validating attacks is going to help you make sure that these are not false positives. And when your detection comes up at the SOC engineers will be able to take action basis with a lot of confidence. So this amount of work will actually go very far, you know. And of course, continuing on the same point, you will always need to be mindful of how much time your detection is going to take to investigate, so that you are able to, your final, one of the big goals that you have is to make it easy for security operations to be able to detect these attacks, right? And how you do that, whether it is by multiple layers of validation, whether it's by correlating multiple log sources, whether it's by using the right kind of responses, right? It's bases you, but it's your skill to, and your responsibility to make it easier for security operations centers to work with your detection content. Finally, you get to testing and documentation. So first part of testing is being able to visualize false positive scenarios and corner cases, right? Where you are able to write down these scenarios and document them before you actually run the tests. Never, I mean, for this is true for any kind of testing, that is, never get into testing without a plan. So you put a plan together, put your thoughts together about what are the scenarios you want to test, and then you begin testing, and not the other way around. Testing scenarios will also, one of the key things about testing is that you will be able to build better test scenarios and better test scripts with demo data. Make sure you have that information available so that you can run those tests and constantly test your detections. Finally, test in the lab, test on the battlefield. Very important. You have some kind of a detection life cycle for your detection rules, right? We'll talk about life cycle management again in a later slide. And then finally document this entire detection for yourself, for your team, for your SOC, for your boss, right? Why do you document? Why do you document a false positive scenario or a corner case? You absolutely need to document a corner case, because if there is a false positive scenario and I mean, so for instance, let's say, take an example, when a domain where AD gets demoted, right? You have an attack that identifies that scenario. But the false positive corner case is that whenever AD actually gets demoted, this alert will trigger, right? If you write this simple fact down in your detection case, in your documentation, the analyst will be able to read that and figure that, oh, yesterday, yeah, we had a domain AD activity and probably they demoted a domain. Let me go check. So it will just help your SOC to quickly understand and analyze that scenario and be able to recognize false positives faster. Please help them. They need all your help. Blue teamers. Okay, finally, maintain your detections. It's not a one-way street. You cannot just write detections and forget about it. You will need to constantly maintain your detections on a periodic basis, set up an audit cycle that will see your accuracy over time, and if changes need to be made, if the and sometimes the attack is not valid going forward. So if the threats die down, it's also prudent to take it off your run list, right? So it'll help you reduce your focus and not get you scrambled with thousands of rules that you need to maintain. Elephant in the room, data sources absolutely deserved a slide on our deck. So the struggle between need and want. I love this line. What do you need? What do you want? And what do you need, right? So everything that you want, you can't have because of course, scenarios. Let's talk about those scenarios a bit. Logs and packets are extremely noisy. We all know that. Logging is extremely expensive. We all know that. That's a fact of life. Now, however, this world works in a 90-10 rule when it comes to log sources and detections. So what we mean by the 90-10 rule, we are saying that 90% of your detection happens using 10% of your data, right? So if you are smart in slicing your data correctly, you will be able to reduce your logging overhead and reduce the cost that your enterprise is paying, right? So you'll always look good doing that. So if you are able to get this math right, then it's very, very valuable. So again, one more time, 90% of your alerts will come from 10% of your data. So if you're able to prioritize the right kind of data, you will get 90% effectivity just from 10% of the information. But there is always a but. No data, no signals, clear, common sense. The bigger challenge, however, comes into validation cases, right? So if you don't have the whole data set, you're not going to be able to validate attacks. And also, the whole data set is usually required when you have an incident, because investigating an incident requires a lot more than what is required in just raising alerts, right? So if you are an organization that thinks clearly, you will need to tier your information in a manner where you say, hey, these log sources are only required for investigations and forensics, while as these log sources are required for actually real-time detection, right? So just a tip. Bonus slide. Clearly, we're running out of time. What are the frame? And the reason I put these there is I'm not going to actually work through these slides, because I'm just going to put some pointers and give you one short line about each of these pointers, so that you can go back and Google some and learn some more and basically improve your craft. So what are the different frameworks for DE? The MITRE ATT&CK we spoke about, the ADS framework that you should look up. It's a different approach. It's a different style. but I think it has a lot of meat in terms of the process itself. Detection as code. I think a lot of this is going to do with what we call detection lifecycle. The life cycle of detection rules is where we are talking about how you create, how you maintain, and how do you deprecate rules going forward, right? So detection as code is going to be very important because you are going to be able to write detection, and if you are able to put it into some kind of a Git kind of a process, then you are able to put detections into uh, development stage, a UAT stage, a pre-prod stage, or a testing phase, and a production stage. So today, what happens is that whenever you create a detection, the detection creates alerts. The alerts go into the SOC, and the SOC has to investigate those scenarios. Now, if you write a rough cut rule, you will produce a lot of noise, and that will send your SOC into a tizzy tomorrow morning, right? So that's a bad scenario, right? Because that's what generates hatred between security operations and detection engineers. So wouldn't it be great if you are able to tag your detections as development stage? So whenever the SOC sees development alerts, they don't bother. Whenever they see testing alerts, they don't bother. Whenever they see beta alerts, they start to look. But whenever they see production alerts, they actually sit down and action, right? So that is what the detections lifecycle looks like, and something that you should look to implement, because that will help you have a very healthy relationship with your security operations center, right? And you'll have friends on the other side. So detection as code is one. Sigma rules is something that you should look at, because Sigma rules will help you transform detection rules from one language to one SIM language to the other. All these SIMs have different query languages. I sat down and built requirements for one of those. I know it's required, but it's a necessary evil. So how do you get parity between these? Sigma rules is perfect. You could scan this QR code. This is a link to a GitHub repository which it's an awesome detection engineering repository. It's got lots of links for you to study and learn. It's just brilliant. I thought it would be important to put it out there. All right. Thank you so much. I'm at the end of my session. The next session is going to be a hands-on session by Cobalt Fox, where he will take you through the process of building detections hands-on. The Blue Team Village is very, very vibrant. We are available on Discord. If you want, if you're going to be part of this community, if you're going to be part of detection engineering, join the community. I'd recommend, because there are lots of superly experienced people hanging there, and the really good conversation. So thank you so much, and hope you enjoy the rest of the sessions.